A system of equations are two or more equations that are graphed on the same coordinate plane. When you're asked to find a solution to a system of equations, what you're looking for is an ordered pair that satisfies both equations. There are three different situations you can have when you graph two lines on a coordinate plane. The first thing that could happen is you can have intersecting lines. When you have intersecting lines, you have exactly one solution, and that one solution is written as an ordered pair. The solution is this point where your two lines intersect, because that's an ordered pair that is part of both lines. You might also have a situation where both of your equations graph the same exact line. That means you have infinite solutions. And you have infinite solutions because every single point in one line is also part of the other line. And finally, you might have two equations that represent parallel lines. Parallel lines have no solutions because none of their ordered pairs will ever be the same. So we're going to look at how you can find your number of solutions for a system of equations by using graphing. Okay. When you graph a system of equations, we're going to use the same method we used when we graphed single lines. The first thing we're going to do is we're going to look for our y-intercept. In this case, our y-intercept is -2, and I'm going to put that on my graph. The next thing I'm going to do in this equation is I'm going to identify my slope. My slope here is 3. And remember, if I want to think of that in terms of a fraction as a rise over run, it's 3/1, which means I'm going to rise up 3 and I'm going to run to the right once. So from this starting point of my y-intercept, I'm going to go up 3 and over 1. And I'm going to repeat that slope a couple of times until I have enough points where I can make a line to show, right there, to show this equation. I kind of got off my dots here just a little bit. Let's see. There, I can make it a little better. Now remember, this is a line, so it's going to go on forever, so we should put arrows on the ends of it. Now I'm going to do the same thing for my second equation, this blue one here. Again, we want to start with our b value, our y-intercept. So my y-intercept is at 4, so I'm going to put that on my graph, 1, 2, 3, 4. And then I'm going to look at my slope. My slope is -3, which again as a fraction would be -3/1, which means I'm going to go down 3 and then to the right 1. So down 3 and to the right 1. Down 3 and to the right 1. And then once I have enough dots, I'll connect these together, make a line. And we can see in this situation we have a set of intersecting lines. Remember, intersecting lines have one solution. The reason they have one solution is because they intersect at one spot. Our solution is the place where our two lines share an ordered pair. So that's going to be our solution right there. So it says if there is a solution, we're supposed to label it in red. So we'll make that dot red here. And then we need to give the ordered pair. So this solution is over 1, up 1. So the solution to this system of equations would be 1, 1. Now the only time you're going to list the solution as an ordered pair is if there's only one solution. If we have no solutions or infinitely many solutions, we don't do that. So let's try graphing this line. Start with your y-intercept, -1. Put it on your graph. And then we're going to use our slope here, slope of 2, which if I think of that as rise and run is going to be up 2 over 1. So from here I'll go up 2 over 1, up 2 over 1, up 2 over 1. Got a couple of dots there. We'll make our line. There we go. Remember that line goes on forever. So we'll add some arrows to it. Now we're going to graph our blue line. So start with your y-intercept, which is 4. 1, 2, 3, 4. We're going to look at our slope, which is 2. 2 over 1, which means we're going to rise 2. We're going to run 1. Since I'm out of room on my graph here, I'm going to follow this pattern backwards and put a couple more dots so that I can make my line. Now hopefully you notice that these two lines here are parallel. Parallel lines will never intersect. Lines that are parallel and never intersect will have no solutions because they'll never have any ordered pairs in common. Now what I want you to notice, and we'll talk about this a little bit later, but a way you can tell just by looking at your equations, if you have the same slope, okay, that means your lines are going to increase at the same rate. Same slope means you're either going to have parallel lines or the same line twice. The way you can tell the difference is by this y-intercept. Okay, so these have the same slope, but they cross that y-axis in two different places. That's why we have two lines here. All right, one more scenario that I want to look at. We're going to look at graphing these two lines. Start with your y-intercept of -2. Down here, -2. This time our slope is written as a fraction, 2/4. That means I have a rise of 2 and a run of 4. So I'm going to go up 2 and over 4. And I can't do any more that way, so I'm going to take it backwards. So instead of up 2, I'll go down 2 and over 4. Good, and I'll draw this line. Oops, I kind of missed that line. Let me try that again. There we go, that's better. All right, so I've got this line here. And now we're going to graph our blue line. Start with our y-intercept, -2, which is down here. This time I have a slope of 1/2, which means from here I'm going to go up 1 and then over 2. So up 1 over 2, up 1 over 2, up 1 over 2. You might notice that all the points I'm drawing are already on that green line. Okay, so this is one of those situations where what we have are we have two lines that are exactly the same. They're graphed right on top of each other. So two equations that represent the same line. When we have two equations that represent the same line, that means we have infinitely many solutions. It means every single point on this line is a solution. So we can't label our solution because there are so many of them. And that's how you can tell what the solutions are, or how many solutions there are in a system of equations by graphing.